Hello, the purpose of this recording is to give you an introduction to Jaspergold model checker from Cadence. The prerequisite for this session is access to the GitHub repository DDP abstraction. If you can go into DDP abstraction, Vinish help Jasper projects. There you'll see 4 different folders which are Jaspergold model checking setup for 4 different designs. I'll be discussing the simple one, 4 counters. It's a simple counter design. Design looks like this. Counters.v is the Verilog file. You have a top level module counters. You have 4 parallel running counters, and towards the end of the module, just before the end module keyword, you will find a section where you write properties and then you check the property. So these 3 sections which start with property keyword are the ones which are the properties. So between property and end property, you will find whatever is written is the property. Whatever is written is the property which needs to be proved or model check, used for model checking. We have P1, P2 and P3. These are the names of the properties, and these are just definition of the properties. For model checking each of these properties, you need to have a always statement, always at the rate positive edge of clock, begin and end. Inside that you use this structure. So assert is a keyword, property is a keyword, and then you are negating the property, and then inside that you are mentioning the property name, which is same as what you have used earlier. It can be P1, P2 or P3. You can use negation or not. In this particular application we wanted to negate it. Another file which is present in this directory is a TCL file for running Jaspergold. If you open it, you can see different setups for running the TCL file, and there is a place where you mention the clock name. This CLK should be same as the clock in the design counters, and then again RST should be same as the reset in the design which you are dealing with. You should be writing just RST if it is a positive reset, active high reset, and negation of the name of the reset signal if it is an active low signal, right? And then this one is the design name of the Verilog file, which is counters.v, and then this is the name of the top level file, counters, which is same as what we have here in the counters.v file. To run Jaspergold, you need a valid license. For that, you can either purchase one, or if you're an IITB student, you need to check if you're connected to IITB VPN and have made necessary and have done necessary changes in the bash RC file. Right now I'm going to check if I'm connected to IITB network. Yes, I'm connected to network, and then the directory where I'm in is 4 counters directory. And to open Jaspergold, this is a command, Jaspergold. Once the Jaspergold window is open, you will see an interface like this. Just make sure that you are in the right directory. Yes, you are in 4 counters, and you have the right TCL file in the directory, which is run.tcl. I'm just going to do source run.tcl. So this is done the model checking, and this is a summary. It says that your property, which is specified in the assert statement, has failed and generated a counter example. In the property table window, you will see the failed properties, and if you double click, there was some error, but you can ignore it. There will be a trace which will violate the condition which you have mentioned in the property. Essentially, what we have mentioned in the property is this. We have property P1 here, negation of P1. So we have mentioned that all the counters are starting from 0, and after first clock cycle till infinity, we either any of the counter value, at least one of the counter value is going to be greater than tick P is 32. So let's go back to the counter example trace. All are starting from 0, and then after a number of clock cycle, which is like starting from immediate clock cycle to any number of clock cycle, we have a value of x4. We have a value of at least one of them greater than 32. 32 is going to be this one, right? So this is a hexadecimal representation. So we can see that x4 has become 32. So that's it. Now this is a violation of the property. You can do many things with it. You can export the VCD. You can process all the information which is given this. If you want to add more signals, you can always click here and then it will list all the signals. You can just drag it here. In this case, all of them are present, but then if there were multiple modules, you can you can go in the deeper levels and plot all the signals. Thanks a lot for watching. I hope it helps.